everyone. In today's video, we are going to cover analyzing functions. Our learning target for today is I can sketch graphs given verbal descriptions of real-life scenarios. First, looking at analyzing functions, we can analyze parts of a function by describing them as either increasing or decreasing, or linear or nonlinear. Now, if we look at the example below, we can describe the parts of the function between x is 0 and x is 4, and x is 4 and x is 8. Now, if I want to talk about x's between 0 and 4, that would be any x value between 0 and 4. So when I relate it to my graph, it's this part here. Now, if I look at this, I have a positive slope. Positive slopes would be increasing, and I have a curved line, so this would be nonlinear. So my graph between x is 0 and x is 4 is increasing and nonlinear. Now, when I look at x is 4 and x is 8, that would be any x value between 4 and 8. So it would be this part of the graph here. Now, when I look at this, I have a negative slope, which would be decreasing. And then again, I have a curved line, so it's nonlinear. So I'd have decreasing and nonlinear. So when I look at functions and their graphs, I can describe them as either increasing or decreasing and linear or nonlinear. Next, looking at distance versus time graphs. A distance versus time graph shows us how far two objects are from one another. Consider what the following types of lines on a distance versus time graph would represent. Notice for all of these examples, we can see that time is our x-axis and distance is our y-axis, because distance will be our dependent variable and time is our independent variable. Now let's also assume for each one of these graphs, we're talking about the distance from our house. Now if we look at part A, this is a positive linear relationship. What this line is telling me is as time is increasing, my distance is increasing. And because I'm linear, I'm moving at a constant speed. So the graph of A is an object moving away at a constant speed. So you're moving from your house at a constant rate. Now, if I look at B, notice as time is increasing, my distance is decreasing. So for this example, I'm moving closer at a constant speed. Again, it's constant because I have a straight line. Now C, as time is increasing, my distance is staying the same. So this graph is an object at rest and not changing its distance. Now looking at D and E, notice I have nonlinear lines. So now I'm not moving at a constant speed, I'm moving at either an increasing or decreasing speed. Looking at D, notice here on my graph, as time increases for an extended amount of time, my distance does not change a lot. And then all of a sudden, my distance shoots up a ton while my time does not change a lot. This is an object moving away at an increasing speed. And then E, notice here I have my time increasing very slowly and my distance is a large chunk, when then all of a sudden my distance shortens out and then my time increases a lot. So this is an object moving away at a decreasing speed. Now looking at example 1, we want to match each distance versus time graph with a correct description. So looking first at example A, it says Kaylee got on the bus at her house. The bus made 2 more stops before it arrived at school. So here we want to look for the one that has 2 more stops before it arrived at school. So if I look at my first graph only has 1 stop. My second graph has 2 stops, and my third graph also has 2 stops. But notice in my third graph, I'm going back to the house, where A tells me the bus made 2 more stops before it arrived to school. It has no mention of going back to the house. So this graph here in the middle would be A. Now, B, Brennan and his dad left for school in his dad's car. They got stopped at the train tracks for several minutes before they were able to continue to school. So here it notices that we say they got stopped at the train tracks for several minutes before they were able to continue to school. So they were only stopped once. Notice in my first graph, I have 1 stop and then I'm increasing back to school. So my first graph is B. And then my third graph, C, Cameron left for school with his mom, but remembered he'd left his English project back at home. She took him back to get his project, and then they headed back to school without any stops. So again, in my third graph, like we talked about, I had 1 stop because they forgot the project. They went back home, and then they stopped at home to get the project, and then they increased back to school. So this third graph would have to be C then. Next, looking at number 2, create a distance first time graph showing Adam's distance from his house. Label each segment of the graph. So here it's talking about Adam's distance from his house. So if Adam's at his house, he'd be on the x-axis. So part A, Adam left his friend Brody's house and started walking home. So here he's starting at Brody's house and he's walking home. So Brody's house would tell me that I'm not starting on the x-axis. I'm starting at, say, a y-intercept. And then walking home would be a linear relationship, so I should have a straight line. So we'll label this part A. Next, part B, Adam realized he left his phone at Brody's house, so he turned around to get it. So here I'm going back to Brody's house to get my phone. So that's B. C, Adam left Brody's a second time and started to walk home. This is the same as part A. So here I'm walking home, again, a linear relationship. So we'll call this part C. Adam stopped halfway to talk to a friend he passed. If he's stopping, time's going to increase as distance does not change. So here I'd have a horizontal line, and that's D. And then part E, Adam then quickly ran home to make it in time for dinner. Now, quickly ran home would tell me that it is a faster pace than him walking home. So I should have a more slanted line here. And then this would be part E. So this is the graph of Adam's distance from his house. Looking at number 3, create a distance first time graph showing Vanessa's distance from her house. Label each segment of the graph. So part A, Vanessa left her house to run at a steady jogging pace. So we're leaving Vanessa's house and running at a steady jogging pace. Notice our example was the distance from Vanessa's house. So that would mean I would start at the origin here because we're leaving her house. So if I'm running at a steady jogging pace, that would be an increasing positive line. So I would have this as part A. Now, part B, Vanessa increased her speed, but halfway got a leg cramp. So, increasing her speed would tell me that's moving faster than her run. So, I would have a even more slanted line as part B. Now, part C, Vanessa sat down and stopped to stretch. So, sitting down would tell me that distance is not moving as time is increasing. So, this is a horizontal line. So, this is part C. And then D, Vanessa decided to turn around and walk back home at a much slower pace. So, we're turning around, going back towards her house, and then walking at a slower pace. So D should be a less slanted line than any of the other lines because I'm walking back home at a slow rate rather than a fast rate. So D would be that line. So this is the graph of Vanessa's distance from her house. In today's lesson, we learned we can analyze functions by describing them as increasing or decreasing in linear and nonlinear. That's a wrap on today's video. We'll see you in the next one.